Hi, welcome back. In this video, we're going to talk about set builder and interval notation. In our previous video, we spoke about sets. We spoke about their intersection. We spoke about their union, right? We spoke about different things in the last video, and we're going to add on to that today. But now, to the set builder, we're going to talk about different notations like interval using parentheses or brackets, different ways of describing what exists in these sets already. So if we have a set, say, composed of odd numbers, and we have another one composed of even numbers as an example, right? We're going to talk about a different way to represent the same information by using different notations. We'll even use a number line today as another way to represent information. So let's get right to it. Let's talk about these notations. So here we're dealing with set builder notation. We know we're dealing with set builder notation because we're using braces here to describe something, right? This defines the variable that we're interested in. So if I had a circle, right, a set, I would call all of the values in there set x. That's the variable I have. This tells me such that x is everything greater than a specific value. That could be some number, right? Whatever the number is. That's how we're going to read or interpret this notation. So if the value was something like, let's say we have the set is all the variables of x such that x is greater than 5. This set will contain all values greater than 5. So 6, 7, 8, 9. All of these values will exist in the set. As you can see, since we're dealing with values greater than 5, we can go on till infinity, right? We're going to be able to continue filling this box with 17, 18, 19. We would never end. And writing all of these numbers is very taxing and tedious, right? So we use this shorthand way of describing it by using set builder notation. We can just say, look at all the x values such that x is greater than 5. And then we don't have to even write all the numbers. We can just think of all the numbers bigger than 5. Now, interval notation, this is coming whenever we use brackets or when we use parentheses, okay? And what we do here is we're trying to describe the beginning and the end. And we separate those two with a comma. So if this example, right, we're going from 5, that's where we're starting, and we're going all the way to positive infinity. It doesn't really end, but it's moving in that direction. It's from least to greatest, right? We're always going to write things from least to greatest. Now, around it, I'm going to either put a bracket or a parentheses. Since this value does not include 5, right, it's everything greater than 5, we're going to use a parentheses because it does not include the number. And notice as we approach positive infinity, we will also never be able to reach it, so we will also use a parentheses. This is the notation we're using for the exact same value. Here I'm saying all the x values between 5 and positive infinity, not including 5. And of course, not including infinity. So everything in between. Had this notation been all the x values greater than or equal to 5, we would have said from 5 to positive infinity, but we would have used a bracket instead because 5 is included. It's equal inside of our set. So our goal is to get comfortable between these notations. I can even use a number line to describe the similarity, right? I can draw a number line here, let's say to the right side. Since I'm interested in everything greater than 5, I can put the number 5 here. And I want to shade everything greater than that value. all the way to positive infinity. Since the parentheses tells me that 5 is not included in the set because it's everything greater than 5, we're going to use an open circle to say that that number does not exist there. In this scenario, had it existed, right, if it was equal to 5, we would have put a closed dot because that 5 does exist, and then it's everything above it. So we can use a number line, we can use interval notation, we can use set builder notation, we can use sets. Our goal is to be comfortable going between all these notations. And that's the purpose of this video. So I'm going to do a few examples. If you feel comfortable after one or two, feel free to pause. And of course, like the video. If not, continue with me, watch the entire video, and see how many examples you would like. So here's one example. We are given set builder notation. Now, this tells me we are interested in all the x values such that x is greater than -2. And, right, this is from our last video. That's the intersection symbol. And x is less than or equal to 3. So what does that look like on a number line? Right? What am I working with here? Something greater than -2 and at the same time less than -3. So let's draw that. I'm going to start with a graph of greater than -2. I'm going to use 0 as my just a location so I can see where -2 would be. -2 would be on this side somewhere. Since it does not have an equal symbol, it does not include the point, so it's going to be an open circle. And since it's greater than that number, it's going to be everything to the right, to positive infinity. Now, on the other hand, we have x is less than or equal to 3. So I draw another number line. 0 is my reference point, and now 3 is going to be somewhere over here. Since there's an equal symbol, we're going to make a closed dot here. And this symbol means less than, right? It looks like the letter L. So it's everything less than 3. And I'm going to shade everything to the left, all the way to negative infinity. Now, what I'm really interested in is I'm interested in the set that involves this and this as well. So I need to combine these two into one. 0 is still here as my reference point. I have 3 on the right. I have -2 on the left. Right? And I'm interested in the intersection. If I had these two sets, I would be interested in the part that overlaps, the part that they have in common. So, what do they share in common? Everything between here and here. See how they're both shaded? The top and the bottom are both shaded. So that means that that part overlaps. This side does not overlap, and this side does not overlap. But the part that is shaded on both will overlap. So I bring that circle, open circle at -2, I bring the closed circle at 3, and because it's the intersection, I'm going to shade the part that overlaps. This is really what I'm interested in. Eventually, we won't need to do 3 number lines. I just wanted to show you 3 of them so you can see how these two are going to get connected into just one. This is ultimately what we want. Right, the intersection of both. Now, how do I convert this to interval notation? Well, since it's an open circle, I'm going to use a parentheses, and I'm going to always go from least to greatest, right? The lowest value is -2, the greater value is +3. Since it includes 3, I'm going to put a bracket, right? So when we're dealing with interval notation, parentheses involves the less than or the greater than symbol, and open circles. And brackets include less than or equal to or greater than or equal to symbols and closed circles. So this maybe helps you see why we're doing a bracket for closed, a parentheses for open. This just tells me it's everything from -2 to 3, not including -2 and including 3. And here we have our three notations, right? We have our set builder, we have our inequality, which is on our number line, and we also have our interval. And our goal is to be able to move freely between the three. Let's try another example. Excuse me. So what does this say? Here I have two parts. I have another circle, I have these two circles, and I want to find the intersection, the part of the two circles that overlaps. So let's draw the line. You can draw this in 3 separate lines. I'm going to show you how to do it in just one. I'm going to start at -2. There's a 0 here somewhere. Right? So at -2, this tells me we're interested in the x values such that x is everything less than or equal to -2. The equal to component makes it a solid dot. And since it's less than, we're going to shade everything to the left. Yeah. This one tells me we're interested in everything greater than 3. So 3 is on this side. Since there's no equal symbol, it's going to have an open circle, and it's everything greater than that. To positive infinity, and this side goes to negative infinity. Now, this is the intersection of both sets. Do these two sets overlap at all? If I were to draw two circles, this has x is less than -2, so -3, -2, -4, -5, all the negatives, right? And this set includes everything greater than 3. So 4, 5, 6, 7, 8, 9, 10. Do these two sets intersect? And the answer is no, because there's nothing that they share in common. So this is actually an empty set. How do we know based on this? We know this is an empty set because there's nothing in between the two. See how this part is empty? And see how there's nothing shaded? That's how I would have known. Now there's no need to convert this to interval notation because there's no solution here. It's an empty set. There's nothing in this notation that exists. It's just an empty set. If you would like to go back to the previous video, feel free to watch that one that explains the union and the intersection of both. Let's try a union example. So what does this tell me? This tells me it's the union. Or it's this set or this set. So let's draw them. Let's put everything in one number line. I'm going to start with the left side. At -1, which is over here, it's everything less than or equal to -1. So -1 is included because of the equal symbol. And it's everything less than. So we're going to shade it to the left. On the right side, I have everything greater than or equal to 3. Since it's equal, again, a solid dot. And it's everything greater, so everything above 3. Since we're interested in the union, we're just saying everything on the left or everything on the right. We're not interested in the intersection, the part that overlaps. So this would actually be our solution. Everything here or everything here would be part of this set. How would I describe this using interval notation? Well, to describe this piece, I'm going to say the smallest value is -infinity and the largest value is -1. Negative infinity can't actually ever be reached, so I'm going to use a parentheses. And since -1 is a closed circle, I'm going to use the bracket. On the other side, meanwhile, I will start at 3 as the lowest value, and it's going to go all the way to positive infinity. 3 is included because it's a closed circle, and infinity will never be included because we can't ever really reach that number, right? It will never be a concrete endpoint. And these two are connected using the union. So the numbers can exist in this space or in this space. So if you're still watching this scenario, I'm going to go backwards. I'm going to walk you through this backward scenario. Feel free to stop at any moment that you feel comfortable. And if at any moment you have questions, please just come and talk to me and let me know. So here we're going to start with the interval notation. What does this mean? This is the least, this is the greatest value in my set. So when I'm drawing this, the smallest value will be -4. 0 somewhere there, and the greatest value is +5. Since it's a parentheses, it means it's going to be an open circle. And since it's a bracket, it's going to be a closed circle. So open circle, closed circle. And we're saying that it's everything between these two. In our previous example, notice how in our previous example we had two pieces of shaded regions. We had the left or the right. And here, we only have one. This is how I know that I'm dealing with the overlap component of things. Had I had two shaded regions, I would have had two sets, right? Because both parts would have had to have been described by those two regions, like we did here. We have to describe the left and we have to describe the right. But since there's only one, I know I'm describing the part that overlaps the middle, the intersection. So let's talk about this. This can be described in several ways. We can talk about, if I ignore the right side of the graph, just focus on -4, we're dealing with everything greater than -4, right? Everything to the right. Meanwhile, I'm also dealing with, if I cover the left, everything less than 5 and equal to 5. So this part can be described like this. And since I'm dealing with the intersection, the part that overlaps, I'm going to put the and symbol instead. And that's how I describe the set builder notation. The value is greater than 4, and it's also less than or equal to 5. The other way you can describe this, you can similarly say that x is between -4 and +5. X is in the middle of all those values. 4 is not included, but 5 is. Well, I hope this has helped. Please let me know if you have any questions. And as always, we'll calculate later.